I'm Nick at the EE WebTech Lab, and today I have ROHM's BD7682FJ series of low-noise quasi-resonant converters. These quasi-resonant converters are used for controlling silicon carbide MOSFETs in DC to DC power converters. Now you might be asking, why use a quasi-resonant converter? Well, quasi-resonant switching reduces turn-on losses at the power switch, which increases efficiency, provides better operating time, and lowers the device's temperature when compared to traditional continuous and discontinuous modes of operation in a flyback converter. Also, the EMI generated by quasi-resonant operation is relatively low at the low voltages and currents where typical application for such a converter resides. It is the intrinsic frequency jitter in quasi-resonant operation that spreads out the noise, thus allowing for simpler and less expensive EMI filters. As I mentioned earlier, the BD7682FJ controls silicon carbide MOSFETs, which are different than traditional MOSFETs because the silicon carbide MOSFETs have a higher gate drive voltage. ROHM's quasi-resonant converters have a window of operation centered around the gate voltage of silicon carbide MOSFETs, which makes them ideal for these types of MOSFETs. So ROHM has provided us this well laid out evaluation board, and it has on the top here the silicon carbide MOSFET. This is a really big heat sink connected to it. And then on the back is the IC on the bottom here. That's a quasi-resonant converter. And what's going on here, we'll be inputting 500 volts DC from the Shelton power supply on the input connector. So I do want to mention this evaluation board accepts either DC or AC. The AC connector is here and the DC connector is here. We'll just be using DC for today. And so 500 volts goes into the evaluation board, and this is a DMM, and it displays the output of the evaluation board. It's about 24 volts, and then this is just a DC static load, and we'll set that up for 1 amp. Okay, so as you can see on the Shelton power supply, 500 volts DC is going into the evaluation board, and the output is about 24 volts, a little 23 and some change there, and the bottom number here is 1 amp, so that's a static load. These quasi-resonant converters have a supply voltage range from 15 volts to 27.5 volts, and operating temperature range from -40 degrees Celsius to 105 degrees Celsius, and they require a scant 19 microamps to begin operation. Other features include soft start function, per cycle overcurrent limit protection, both over voltage and overload protection, brownout protection, and a current mask function. And finally, ROHM guarantees long-term support for these devices, which is very important for safety and EMI testing. After all, if a customer's board has to get spun to accommodate another or a new converter, then retesting for safety and EMI is required, which can be expensive and time-consuming. For more information, visit rohm.com.